to, I don't know if that's my echo or you guys hear it. I'm going to share my my slides here, but it's informal group, so feel free to raise your hands. I'll try and pay attention, ask questions. Just hopefully it will make it interesting and informative for you. So let me share my screen here. Okay. Uh, can you guys see the presentation, Ron?
Yeah, we can see. Thanks.
Okay, excellent. Well, very good. So, just to set a little bit of a stage, I think all of us are obviously really aware that AI is the big thing right now. It impacts all of us. I know when Haran and I were chatting, I think roughly 50% of the medtech group is computer science and engineering backgrounds, and 50% sciences and medical. And AI really is going to apply to everything. But I think the question really is like Satya Nadella here is intimating is, okay, great opportunity, but how do we deal with the consequences? Like, how do we think about it? What are the kind of things that we need to do? And I think a lot of the work that we're doing really tries to tap into how do we make AI, how do we make data discovery and data kind of work more trustable? That's really a lot of the reasons for what we do. That's kind of behind the scenes in our DNA. So a little bit about me, and Ron, thank you for the background. I actually even forgotten my British gas days. That was back in the day. I grew up in the UK. I grew up in Brighton, so I'm British citizen, but I've been in the US for a very long time. But yeah, this is kind of like my little journey along the way. And yeah, I would say what was maybe relevant to you guys and where you're at in your career is that um, you can kind of take a journey that hopefully at some point gets you to what you really want to do and you really are kind of very passionate about. But you figure out what are some of the stepping stones because it's not like, I mean, all of us probably want to run our own business and be our own bosses and and really make an impact in the world. I think that's maybe part of my motivation, but there's definitely you know, there's lots of ways of getting there, and this is my path. And I think it's okay if you're not exactly where you want to be right now, especially I think these days. I think, again, back with AI and some of the emerging technologies, there is some like brand new paths that are, that you guys are creating for yourselves, right? So, and if it's not quite there at the minute, you can still maybe get there. So anyway, Haran, you did a good job with my background, so I'm not going to go through it anymore. So who is Acoer? I think that's maybe a little bit more relevant. Um, the core team, we've been together for many years now, actually, since the CDC days. And I mean, my business partner and CTO, Ben's case, for I want to say almost 15 years we have worked together. So we are quite a technical team. That's all of us really are technologists by profession. I am, as you probably saw from the journey. However, we've also been building businesses for a long time. I do all kinds of things. I lead all kinds of things in, I would say, the decentralized health space as well as in the crypto blockchain space, and we've been around for a while and publish books and things like this. But really, I think what the company wants to do, what Acre wants to do, and what we're, I think, good at is this merging of some health innovation with, if you like, technologies that improve trust. That's really, or decentralized data that maybe lowers costs and gives more ownership of data to people who actually own it and democratize and things like that. So, but let's kind of jump into this a little bit. Haran asked me to kind of give a little bit of background about like, what is blockchain? What is it used for in healthcare, and then progress, from there. So that was my thinking about this. But I think with anything, you got to kind of ask the question of like, why are you doing this stuff, right? I mean, we can talk about the what, and how, in very big detail. But I think it's important to understand like why. So this is what's happening in clinical research, but I would say it's largely applicable to all of health, digital health and health innovation, which is this concept of EROM's law. You guys may have, I'm sure you probably have heard of this. Moore's law, certainly all of us have heard about technologies getting, oops, sorry about that, my chair. Thank you. Can you guys still hear me? Okay, yeah.
Yeah.
Yes. So anyway, technology is getting faster. We're becoming more productive every 18 months. And you could argue, and I think many of us will argue now that with AI, even Moore's law is a little bit obsolete, right? It's actually a lot faster than 18 months. If you're just looking at, for instance, generative AI, or you're looking at even like some of the new things around agentic AI and things like this. However, let's just stick with Moore's law. Unfortunately, in data over, we can see 50, 60 years, 70 years, the literal reverse has been happening in clinical research. Clinical research has become more expensive and slower and less, really less useful. So a lot of money, a lot of resources, but not results have not been that great. And we've seen this everywhere. And I think the unfortunate thing here is that there's a direct human impact. We're not just talking about money or resources and esoteric things. This impacts humans. I think perhaps the only exception to EROM's law that we've seen in recent times, is around COVID and the vaccinations for COVID and the effort, even the collaboration on that. But we could do more COVID-like innovation intentionally, not waiting for a pandemic to kind of force that to happen. So, so why is this happening? I mean, honestly, there's not a lot of, if you think about other industries, which are also regulated, like construction, education, where you guys are at, financial services, you name it, there's a lot of bureaucracy there. There's also a lot of regulations and compliance and things. So the crutch that's often used, which is, well, we're talking about private data or there's a lot of regulations. I mean, it is just a crutch. In of itself, it doesn't really explain why this has happened. But what I will tell you, at least in the U.S., and though it's really prevalent in Western society and Western countries, is that in the healthcare space, very, very few companies have massive monopolies, and they're really incented to not cooperate. They're really incented to be opaque. They're really incented to keep doing the same thing they've been doing. Pharma companies, pharmacy benefits managers, insurance companies, you name it. So this has become a thing because in a capitalist society that we're in, these people make enormous amounts of money and largely unaccountable. So it keeps continuing, but we can make some changes. So I mentioned we have some motivations, kind of, and I explained some of the problems that we see. Basically, there is definitely distrust and loss of confidence in the life sciences healthcare space. I think there's all kinds of data to back it up. There's all kinds of anecdotes to back it up. I mean, I'm sure you guys, all of us saw this. Not that I would ever condone it, but the CEO of United Health Insurance, being shot on the street and all the sentiment that came out, right? I think if nothing else, that kind of shows you how people feel about this industry, and so I would say a lot of it actually is quite justified. One other little bit of information for you. Again, you probably noticed in the US, about 20% of the gross domestic product, that's about $6 trillion goes to, or projected to it's 4 trillion now, but projected to 6 trillion goes to healthcare. So it's 1/5 of the gross domestic product. And of that, there's about $1 trillion of wastage. So $1 trillion is enough to run the gross, domestic product of many countries, right? That's a lot of money. But and unfortunately, much of that money goes to stupid things like redundant work, things that don't really add value. So therein is the opportunity. I think that's the good thing for people like us is, we can make a difference. What we're trying to do is ultimately figure out how do we improve trust and confidence in data. And healthcare, really, life sciences, pretty much every industry, but it is about data. That's what moves the needle, right? Whether you're talking about medical devices or wearables or treatment protocols, um, building new proteins, whatever. I mean, it is very much a data game and very fast moving, very big, very siloed data. So there's reason why people need to figure out how to improve trust and confidence in data. It is a data problem. So moving on, that's a little bit of just kind of our motivation, but this is not my picture. It's from a third party who does this kind of info charts, but you'll get a sense here. This is US centric, but I think again, with the NHS and some of the private insurance in the UK, there is a lot of commonalities to this. But the net of it is, this is me or you, one of us. We're the patient. We're talking to our doctor, and we're sharing information, private information about our health, right? But then there's a lab maybe because you have to have blood drawn and pharmacies, and then certainly in the US there's multiple insurance companies and there's reinsurance companies and there's a whole triad of insurance companies. So they're involved as within the primary data source, but then very, very quickly, like people lose the plot. Like, I mean, it's the data just gets um, basically divvied up by more and more and more intermediaries along the way, all of whom somehow make a lot of money. But the further you go to the right, the less that data is, or that process has any kind of direct relationship with the actual individual. Certainly, the individual, like in these layers of secondary data or third layer data and so on, has no clue what's going on, much less being incentivized to participate or being having some kind of in-kind value from it. None of that. So all these people basically take the data, they make a lot of they have like really big businesses built off of it, but very much disconnected from the patient. So that's not a good thing, right? I mean, that's not like we wouldn't allow, as example, for anyone ways out, though it is happening, but just not as overtly and as kind of arrogantly. We wouldn't allow them to tap into our bank data and all of our financial data without us having some kind of consent or some kind of like active um, kind of active intention about it, right? But that's not the case here. So, all right. So, what does that got to do with blockchain? Well, blockchain really is digital native. It's really in the simplest, if you think technology in the simplest form, it's a database. It's a distributed database, which is nothing that special. It's been around. Distributed database has been around for a long time. So what else is different about it? Well, it's got this idea of tokens, right? And the tokens, again, if you think technically, it's really about um, improving security of a network. So where you're doing transactions and you're recording some kind of information on a like a public ledger on some kind of a, if you like, database that has public interface. But then the tokens improve security because you have people who own some of the tokens and they use it to maybe validate a transaction. That's called validator nodes and things like this. Or they're using the tokens to essentially vouch. That's called proof of stake. Like they're like using their if you like their social currency to like vouch for a transaction. And then if they do it and they they basically approve a transaction, they get a small fraction of the fee of the transaction for their troubles. That's the basic idea. But the real thing though is the actual data is almost always not on the chain. If you're trying to use blockchain, the question is, well, where is the actual data? If you exclude cryptocurrency like Bitcoin, which is natively on the Bitcoin network, or some of the new cryptocurrencies, the altcoins and things like this, just about everything else, use cases, um, the data is not living on the blockchain, even if you move it there, which certainly in healthcare, we would not do that. There's privacy issues, there's compliance issues, there's data ownership issues, all kinds of things. So the things you got to be thinking about is, well, where's the data? Like where's my data specifically, not just data in general. Can I get to the data? Can I trust the data? Once I go through all that, what can I do with the data? Can I just read it? Can I update it? Can I share it? And then ultimately, like things like as we go down the path, particularly tokens, this idea, well, who's accessing the data? Are they supposed to access it? If it's my data, like, did I consent to them doing it? And things like this. So that's where we kind of gain to this idea of, if you use blockchain technology and you do it properly, because you can do it in lots of bad ways, you really are trying to remove after having to ask Jim or Haran, hey, is my data safe, or did you access it? You want to use computational mathematics, or what I think of as computational trust. That's the reason. If you didn't, it's not just about trust, because you could argue that, well, we trust NHS, NHS trusts Cambridge Analytica, and so on. But the point here is all of these, at the very least, even if they're trustworthy organizations, they're centralizing the trust into one entity that has their own agenda. And their agenda is often not what our agenda is, right? Like Jim's agenda is not the same as Amazon's agenda, right? Even though a lot of my data is living on the Amazon servers. So by having blockchain, we can basically kind of nudge towards having mathematical algorithms providing, like basically in real time, providing trust components. So that's really, I think that's where it starts. However, it's by no means where it ends, and there's a lot more. One thing that I kind of think about when it comes to blockchain is this idea of the Hawthorne effect. I don't know if you guys have heard of it or not, but there's basically this human psychology concept that, if you're being watched, you tend to be a good actor, because you're being watched. And now if you take that idea and scale it and make it more of a systematic point of view, if you knew that every transaction, or every important transaction that at least you have consented to, or is part of something you care about, is being watched, and everybody knows it, not just you. All the players know that there are cameras. You tend to be a good actor. It's much more difficult to be the outlier, right? And then you see here is this idea that it's not just one place. Everybody's not looking at just one person. It's, we're all kind of there, and there's a decentralized view about this. All right, so I did mention trust isn't the only thing. There's a lot of other things you have to think about when you're thinking blockchain, and like why blockchain or how blockchain, things like this. Where I start, because we build software in this world of blockchain and healthcare, really this is our starting point, is economic viability. Like, can we do this? Can we provide basically verifiability for transactions of different kinds? But can we do it in a way that we can afford to build it and our clients can afford to pay for it? And we can ideally, especially for healthcare, build it so it just happens behind the scenes. And I'll give you an example, like when we are doing, for instance, email or SMS or whatever, they're behind the scenes, there are protocols, there are internet protocols that make that happen. So for email, it's this thing called SMTP. So we don't really care. Like when I'm getting emails from Haran, I don't really care about, like what were all the, like the underlying, services, APIs, kind of routing technologies used for that email to happen. I just care about the email getting done, me being able to read it in English and respond. So in order for us to do that with blockchain, to provide this layer of trust, we got to really think through, all right, well, if I have a trustworthy email and I'm sending back and forth to you guys, in Nottingham, you know, are you willing to pay extra money for it? If I said, well, every time I send emails to you guys, it's going to be another $2. I mean, how is that going to go by? So I think that's where we start. So we like, and there are not too many protocols or too many blockchain networks, if you like, that have stable prices. Most of them have their variable prices, we have so-called gas. Some networks, such as Ethereum, at least they used to be insanely wild and very, very expensive, demand-based. So the more people, who are minting, I don't know, Bored Apes, the more expensive it would get to basically mint that or create that non-fungible token. But there are some other technologies, particularly more, I would say, next generation, newer blockchain, where prices are significantly lower. Even if they're variable, there's basically a ceiling on the price. So you're not going to go from like 1 cent or 1 penny per transaction to 15 pounds like for the next one. It's a lot more stable. And then there's also technologies like the one that we use called Hedera, where the pricing is actually pegged to US dollars. So regardless of how up and down the native token price goes, where our price is like it's going to be 1 cent or 100th of a cent, for instance, for a simple transaction. So anyway, I won't go through all of this in that level of detail, but I would say just kind of really figuring out what is important in terms of being real is hugely kind of it's a huge real life element, in this, because otherwise you build things that are very cool, but then you can never have them adopted. Nobody will buy it because it's just too expensive, or it consumes too much energy, or other issues with sustainability. So anyway, characteristics of the platform, I mentioned sustainability. Governance is basically, like what's happening. So if, as example, you spend a year building some very elaborate, decentralized science application on a network, and then the 5 core developers decided that they wanted to like change it or fork it, or they no longer got along, and like there's the new, kind of rogue group is going to set a whole different protocol based off of what you had built on. Those things have really big impact. So this governance is a big thing. The transparency on how the treasury is being used, the tokens that basically they manifest and they use for network security and to drive incentives. All those things are really kind of important things. And the more you kind of do in this, the more you realize you really need to be in a place where those are stable, right? Like you can't, the governance needs to be something that's transparent and stable. They can rely on it. Tokenization, similarly, where's treasury? It's just one or two like people or companies controlling everything. These are all like really important things that further down you go in building things. And then I would say lastly, but certainly not least, and maybe something that's really important to you guys is like, okay, if I'm going to build on this network, what kind of tools are out there? How many other people are doing this? Is it open source? Are there like things that accelerate me building like a decentralized science solution? If I want to, as example, build a, let's say kind of a decentralized genomic bank, a genome bank, are there things that help me do it, or do I have to figure everything out from scratch? And if the answer is, is the latter, maybe that's not the place to be, because you're going to spend so much of your time building infrastructure and not really enough time doing useful things that you want to do. So I have lots of things. Basically, this is how blockchain technology has evolved over the last 10, 15 years. It started with Bitcoin. And Bitcoin is still, to be clear, very, very relevant. It's relevant as a currency, but it's also relevant as the idea of decentralization and removing censorship or censorship tamper-proof and things like this. There's some really important concepts that Satoshi Nakamoto brought up back in the 2008 paper that still apply 17 years later. However, the technology has definitely moved on, right? Bitcoin is by no means efficient. It's designed not to be efficient with the proof of work and all these things. So where we're at right now is kind of like really much more nimble, much faster, much cheaper, much higher transaction type blockchain or really decentralized ledger technologies, DLT, and that's kind of where we're at. We build our technologies using next generation DLT as opposed to like Bitcoin network or Ethereum. Um, so just bring it to healthcare. Like, how does it actually play out in healthcare? Yeah, I mentioned we're not going to put patient data or population data or things like this on the blockchain on public ledger. That doesn't really make a whole lot of sense. So how does it work? The way it works, at least for us, but I think this is the best practice for healthcare, is that you're going to have your private data, like your patient data or your I don't know. In our case, we do a lot of work with opioids in different states and counties in the U.S. That data is secure and is not on the chain. That's within firewalls or it's within secure kind of like secure platforms that are not directly connected to the blockchain. However, there is need for basically having some kind of transparency built in or some kind of verifiability built in. So we can say, oh, we trust that Jim and Haran spoke. We just don't know what they spoke about. So that's this idea that you can broadcast messages to a public ledger. And the way we do it is that all those messages they're basically encrypted. In our lingo, the payload is hashed. So, and then what happens, and that kind of goes to provide some kind of, messaging to the public ledger. And then from the ledger, what you basically get is like a finality, which is that, hey, we got your message, cool, and we have finalized it. This called finality, and we've all the other nodes here have basically got a copy of this message notification. So it allows you to then later on go back and say, hey, did Jim and Haran actually ever speak? And then there will be proof that says, yes, they did, but nobody knows what they spoke about, which is important. It's really important to understand that we're not, when you're talking about public ledgers and networks, it is not like a binary, we tell everything or we don't tell everything, right? There is definitely some nuance, in that. All right, so I'm going to stop here. I don't want to just keep going. I'm happy to, because I was kind of like just talking a little bit about, the reasons and blockchain and things like this. But before I go further and talk about what Acoer is doing, I'm happy to stop and take any questions if there's any. See if there's any hands up. Okay, I guess not. Let me know if you guys are asleep. That would also be a problem. All right. Okay. I think I don't see any hands up. Yeah. I see Jacob is laughing. Yeah, he's seen me at work before. It's like, Jim, this is not the first time we bored people. All right. All right, Jake, I'm with you. Okay, moving on. You guys feel free to stop me as we go. All right. So, all right. So what does Acoer do? What is our vision? What are we doing for real? I think this is probably more interesting than some of the other kind of things. So really our whole idea is, we have a lot of expertise in connecting siloed health data. That's really where we came from, and building really big technologies in open source and at the CDC and in pharma, things like this. So we kind of making health data connected. That is a thing because the data is not connected by nature. It's siloed. It's in different formats. It's in like fax and all kinds of like really archaic things. So the next thing is how do we make it usable? Like how do we kind of have, whether it's a user experience like with an app, or these days in recent times, we've done a lot of work with agentic AI, things that is really machine to machine being usable, and therefore using interoperable technologies. This technology called FHIR which is really FHIR is basically like a health spin on the internet interoperability protocols, the REST APIs. So anyway, how do we make the data usable? And then finally, I think this is the thing that significantly differentiates Acoer from many other companies in the healthcare world is how do we use cryptography to show verification, to make things in our lingo cryptographically authentic. And then in terms of like what we do, we're really trying to improve lives. Ultimately, that's what moves the needle. We think that's where the problems are. So this is not just, we're not just trying to like create tokens and pump them and dump them, and just create some kind of a financial arbitrage. That's not really, we're motivated by like real things. Like, are we doing things that actually somebody cares about? Like, is this going to help people, with, for instance, with relapses in substance overdose to be able to get better help from public health, or have help law enforcement be able to identify fentanyl, black cells much faster because we have the data. That's really what and then data that can be trusted, that is built on these technologies to impute being more ethical and responsible. So that's really this is what motivates us. But then, okay, that's great, like pie in the sky, we're trying to save lives, but how do you like make it work? We're trying to lower cost of data discovery, because ultimately it's great if I go and talk to like a C-level at I don't know, Novo Nordisk or something. But they're going to say, okay, that's great, Jim, love it. But you guys are not Bill Gates, it's not, you're not an NGO. Tell me how you're going to like make my life better. And oftentimes it's about lowering your cost. And that's the reality of it. So we do quite a bit of work on connecting to decentralized data at rest, using this technology we built called the cryptographic data mesh. So we don't have to re-centralize the data to get like AI done. So we don't have to put data back onto Amazon and build an intelligence layer on Amazon and all this kind of stuff that is very costly, but what's currently happening. And then finally, healthcare has a lot of regulations. There's a lot of compliance needs. So if I'm talking to a chief compliance officer, they're going to care about, hey, prove to me that you're more secure, you're more private, you're more verifiable than the products that we use. And if you can't do that, then we're not going to really be that, excited about what you're doing. So, all right. So I mentioned decentralized data. One of the things we've been doing recently, particularly with AI, is this kind of this concept of federated learning, which is decentralized AI. So we're on the left-hand side of this picture. This is a lot of the data that I think people like those of you guys at 50% who is doing sciences or medical. This is probably your kind of bread and butter. You're dealing with data that you get like informed consent and patient health records, that maybe you have synthetic data access, lab results, tox results, etc. If you're dealing with like what's called real world evidence, patient reported outcomes, maybe some genomic data, things like this. Pharmas deal with regulatory submission. So all of these are real examples of our clients and the kind of data that we deal with. But this data is really controlled. This is a trusted environment. This is not on the public internet. Then on the right-hand side, we have other data sources that are often needed to provide an inflection point or mesh or improve the understanding of this or enable it better, such as working with academia or research boards or CROs that help with some of the processing. Data aggregators, you saw my little chart with all the different data companies that are involved. Of course, government, health exchange, there's so much. So, one of our technologies and the way we think is, okay, how do we mesh these? How do we learn from these without making a giant data ocean from it? Because I can assure you, nobody in the left-hand side wants to give this data to anyone, much less to just provide it over the top to these entities. So data you trust, data you don't trust. And it turns out there's ways of going about this. It kind of gets into decentralized learning and things like trusted execution environments and doing all kinds of like pretty fancy cryptography, etc. So I mentioned, we're trying first and foremost, outside of all this technical, kind of jangle, we're trying to solve real problems. So our flagship product is a product called Health Data Explorer. And really what we're doing is working with medical examiners, coroners, forensic pathologists, people, actually cut people out for real. That's our clients, many of our clients, and the kind of work we're doing, this is like, this is like real comments from them. It's like, hey, we get tox data from all kinds of different places. It needs to be formatted. We need to get value from it. You guys help us do that. There's a lot of administrative burden, which is a really big problem across all of healthcare. All physicians have this. This is probably the number one complaint that physicians have. You're making my life more difficult. I have to do more data entry. So we automate things. We make it easier. We aggregate stuff. Data insight is a really big thing, right? So people spend a huge amount of time in this space trying to get the data and then figure out, okay, like what the hell's going on? Like I need a chart. So we do that proactively, and that's one of the key reasons why people like this. And then sharing the data, but sharing it ethically, sharing it in a verifiable way, not just like putting on an email or on a Signal group chat and including journalists in it, which apparently happens. So anyway, that's kind of what we do. If you have, Haran, do we have time for me to do a quick demo? I don't want to have a.
Oh yeah,
have to do it. Do we? Okay. So let me show you, because I think a lot of these things are kind of, they're not that mysterious, really. But so here, let me make this a little bit bigger so it's visible. So I mentioned we have this Health Data Explorer. I won't go through everything. We have lots of things, and we don't have time for doing that. But I'm happy to talk with you guys offline if if you're interested in this kind of stuff. If it inspires you, whatever, happy to do it. If not, that's cool too. But I want to kind of give you proof that these things are real. I'm not just like telling you things because it sounds sexy. So anyway, so this is our Health Data Explorer, and our clients kind of come in. They typically have lots of different what we call workspaces to go to. I'm going to go into this one. This is synthetic data. I'm not sharing private data. But what our clients want to do is go in there. This is like a chief medical examiner as example, or a coroner or something like this. They want to first and foremost kind of get like results on or metrics on how they're doing, like how many autopsy or death certifications are done by pathologists in a certain amount of time. What are the patterns? These kind of things. So things that you would kind of expect and be able to isolate, by a particular person or a year or whatever. All these kind of things that, and then be able to save it in different forms. But then the really exciting things for them is this idea that there is the ability to do analytics on data they can trust. So this is a very common thing to kind of come in and, you can see there's all kinds of dashboards built in, and they can dice and splice this data in any which way, but oftentimes they come in and they're typing something like fentanyl, and that cuts across the data, and then maybe they're kind of going down, I don't know, maybe they're looking at fentanyl toxicity specifically. They're looking at demographics, and I'm sure, I don't honestly know if the opioid pandemic or epidemic is if the demographics apply the same way as they do in the US and the UK, but it's certainly used to be a middle-aged man problem historically. It has changed, especially with fentanyl. The profile has changed significantly, and we have seen this. In fact, we have provided real data to show the community that the underlying patterns are changing. Like right now, as example, in the last few months, there's been almost no mortality due to heroin, but a huge amount due to fentanyl. And that's because there's a lot of synthetic fentanyl that's being put into all kinds of drugs without people knowing it. But anyway, not to get into all of the science, but people dice and splice. But then this is where it kind of gets exciting, because I showed you this idea of things that you do own and things that you don't own. So now we're going in, we're meshing in geocoding data, and we're meshing in some law enforcement data. So in this case, this is a generic police department, but for our real clients, it will be real police departments and real district attorney agencies and things like this. So, and then examination data, again, lots of different ways. This is a common thing that our clients do. They isolate by heart and brain size or things like this. But then ultimately, all this stuff goes back to cases. That's how the data. So the data is stored originally in a proprietary system as a case. But then we provide all this aggregation. If you wanted to go back to the case, we provide it in this way. But this is really where we significantly differentiate from anyone in our field, which is the ability to basically, and this is where we use Hedera as a technology we call this the Acoer verified mark. We basically, every time you go in here and you're looking at the case, we are doing an encrypted payload comparison of what you see on your screen or what is the information that's there with what was recorded here. So, and we're saying, is this still the latest? And we're doing all these things proactively behind the scenes. So you don't have to do it. You don't have to wait for it. We're just doing it. But then you'll see here as example that we have tox data, but the data is coming from multiple files. It's not from one file. And we have many examples where we have like 7, 8, 9, 10, 5, multiple files. And we're doing the same kind of the same idea of verifiability at the individual data set level, as well as the changes to the data set, as well as the case level. So then if you download, let me download the tox data because it's more interesting. If you download this data, and then you want to do other things with it, that data, is you basically trust it. And we have lots of ways in which we've kind of proven that data is trustworthy. So what the hell is it? Downloads. Again, you don't need to, this is not necessarily that exciting, but you can see there's a lot of data here. So being able to trust this data and then be able to share it properly is really important. I'm going to stop here because I know we don't have a whole lot of time, and there was a couple other things I wanted to mention, but all to say that's a really important thing. It turns out that being able to share this data, being able to verify the data is real, that the analysis that you're getting is really important. I will show you one other thing real quick. Since I mentioned that this agentic AI stuff, I mentioned the toxicology data. One of the problems in this world is this world of mortality data and things like this is that the data is coming from, like, for instance, from lab in a PDF form or some kind of archaic digital form, but you really need to get value from it by doing some transformation, extraction, things like this. So I'm just gonna kick this off this very quickly just so you have an idea what is going on. This is what the actual tox data looks like. If I can find it. Yeah, so this is what the tox data looks like. This is, probably those of you guys with a medical background, you may be familiar with this, but very valuable things, very valuable results, and some discoveries, and it's called panels that it's basically locked up in a PDF. And what we're doing is basically we're running an agentic AI, and we have a watch for production. We have a watch AI that reads this, but you can see we're providing as soon as we can, but we have trained our own language model and running in a private setting. We're providing toxicology results. We're doing it's generating a fire bundle behind the scenes, but this kind of thing is important because it helps the pathologists, the toxicologists, and then they use their experience with the things that we're giving them. And then this data, as well as the interoperable version, goes back into our analytics system. I did mention very quickly that we do some other kind of fancy things behind the scenes. So for instance, we track the actual AI model using a blockchain. So that's the current model, but you can see how it was deprecated. We actually, those of you guys who know like tokenization, we actually use an NFT for the tokens, and all of the variations and transactions associated are related to this unique NFT. So and all that, we kind of have them on, we have through this transaction ID. I won't go through all of it. It's kind of a scary looking page, but we're able to show what we're doing. We're able to show that, we're privacy preserving and all these kind of things. We do full, again, traceability on the transactions. So that's, the extraction process and all of this. And again, we have a transaction ID to a blockchain that shows the proof. And then we do this kind of this decentralized connection to through our cryptographic data mesh. So as an example, we're using this technology called gvisor, which is a pretty sophisticated security enclave, and we're running things like secure C and all kinds of very privacy preserving type of things, but we're also using blockchain to be able to like open it. So you can see that that's our data cloud provider in Seattle that I just closed the connection. But if I reconnect it, I'm going to have to reconsent to do it. And we use an NFT behind the scenes for doing that. And I'm gonna you can kind of see what's going on there. We use a consent token, and this shows all the associated transactions. Anyway, I won't go through all of it, but I can show you that all these things, that there's some kind of like this idea of verifiability is really important to what we're doing. All right, I'm gonna go back to my presentation, and now since I've already talked through these, I'm just gonna wrap it up. Haran did ask me to just like, hey, what is my perspective of what is the future in this space. It's exciting. It's a little bit scary too, to be honest, because things that we've been learning, some of them we're gonna have to think about differently because AI is a really, really big thing. But then I think the opportunity is, well, how do we do AI better? How do we do it more ethically? How do we build solutions for decentralized data and keep the data validated where it is? Don't move it around. How do we do AI on-prem? As opposed to just use, OpenAI's infrastructure, which gives them all governance. I mean, if you're using OpenAI's infrastructure, they own the model, obviously. They own they certainly have access to your data training, and they own the governance, right? So, for most like pharma companies, who are really hung up on intellectual property, that's a really big problem. It's a big problem for us dealing with, like data that's owned by states and jurisdictions. Like they don't want that data to be, to go on ChatGPT and inadvertently create, like a privacy vector. So more efficient AI. I think this is a really important thing because look, it's great that Anthropic and OpenAI are using 500 million or 500 billion tokens like variables for training, but we don't need that, and we sure don't have billions of dollars to spend to do it. If I'm doing a talks data, like specific talks data training, maybe I need 10,000 variables, right? I don't need 10 billion. But how do I do it? How do I make it more like small language model, more specific to what I'm really doing, better multimodal training, things like this. I think these are areas where we need to be more ethical and not just trust that, that Sam Altman's going to be able to, he's going to be looking out for our well-being in the future. I think explainability is a really important thing. And those of you guys who are familiar with the FDA guidelines on this, the FDA has mentioned this, that if you're doing AI for patient safety kind of use cases, you must be able to explain like how you got there and show some traceability. Those of you guys, in Europe, there's the European health data space regulations. So that explicitly is also asking about provability and protecting people's rights. So that's really kind of important. I showed you lineage tracking. I think ultimately we need to be able to show with cryptographic proof, like what happened to the model, like what was the machine to machine interaction, the human to machine interaction, where is the data integrity, potential data integrity issues or hallucinations, non-compliance, you name it. This is a big thing. And it's the kind of thing that I think actually is going to move the needle because people want to do AI, but people are also going to say, I don't want to give you my stuff. You have to prove that you're legit. And then I mentioned governance before in the context of blockchain, but it also is very, very relevant in context of AI. Like, I mean, it would be insanely bad for society if we don't learn from the internet being owned by 5 companies and then basically make AI owned by 5 companies. But that's exactly the way it's going, right? So we have to somehow find a way to not make, the Magnificent Seven and NVIDIA like the only people who have a stake, in the future of humanity, which is, I mean, honestly, it's a possibility if we don't do something about it. All right, so what's going on with AI and life sciences? There's a lot going on, but what's exciting to me is you can see there's genomics or imaging, electronic records, molecule simulations, things like this. They're getting more and more mature, right? And ultimately, you're trying to drive through all these different things, get to better decisions, and improve clinical outcome. Um, we can spend a lot of time talking about DeSci and very confusingly DeSci AI, also pronounced DeSci. Uh, so going from decentralized AI, right, decentralized science, open access, transparency, all these things that have been around for a few years to AI that we talked about to like more now, well, how do we merge these things? And then I think in the future, this is my spin on it. I think people, but not necessarily many institutes, to be clear, right? I mean, I can't imagine Epic will want to have more decentralization or private or improving privacy and things like this. Like that's or OpenAI, but many, I think people like us hopefully care about these things, improve privacy, improve automated AI integrity, and better tokenization to do participatory AI, do participatory patient engagement, user engagement. I think, and I don't know if Jake is still on or not, but I know you're doing tons of stuff with agentic AI, which is fantastic. But then the more agentic AIs you have, I mean, there's one gym, but I could easily have 1,000 agents. But then the thing is, well, how do you orchestrate amongst all these agents for machines, for people, for organizations, for use cases? And that's a really complicated problem. Like technically, it's a very complicated problem. And it taps back into tokenization. It really, I mean, the regulators forget about it. They have no clue what's going on about this. But this is a really big thing. And then usability is a really, really big thing too, because we're going to have to suspend our minds about what usability is if we're talking about agents talking to agents. Like if my my talks agent is talking to Haran's payment agent, and we're exchanging micropayments. I mean, people are not involved. Those are all things that are happening at very big scale. So, but what is the usability? And is every company going to build their own usability? That's not going to make sense. And certainly this idea of a companion for AI, I think, we've all seen that that's a little bit passe. Like, it's great to have a companion for ChatGPT, but do you really need a companion for Acoer, AI? Probably not. So last slide, I think I just want to leave it at a positive note. There's a lot of really interesting things happening in the world of DeSci. This is from Masari. I encourage you guys to look into it. I think this is the future. I think for people like yourselves, forward thinking in medical, want to do good things. I think I would look into these things. I would look into the ecosystem and communities and some of the funders. You'll see our name is here as well, Acoer. But yeah, to me, this gives you guys some very discrete things that you can investigate and maybe inspire you to do good things. That's it from my end. Hopefully, I didn't put anybody to sleep or any more than I did with Jake anyway. You guys, Ryan, are you still there? I
Yeah.
want to make sure. All right, cool.
Thank you so much. That was really inspiring talk. So I mean, yeah, I mean, blockchain AI is just some examples of technologies that we've heard a lot about in the news, but it's actually really inspiring to see the real world application, like within healthcare and with the demos that you showed us.
Awesome. Thank you. I appreciate it. Sorry for being a little bit long, but it's a difficult topic to do it justice if you don't give a little bit of preamble. So that's what I was trying to do.
Yeah, that's true. So I guess maybe one question from me. So what would you say are some of like the main reasons why, let's say, like your company works with Hedera, like what are some of the advantages that you see with them?
Yeah, that's a good question. I would say that the original answer for it goes back to years ago, which is like maybe 2018 or so, give or take, very, very early in Hedera's kind of world, which is we were looking for a technology, a blockchain technology that would allow us to do lots of transactions cheaply, and fast, but also something that wasn't fly by night. That would be around, right? Again, so we did some evaluations. We did build uh, before Hedera built on Ethereum and had poked around with some other protocols, but then came across Hedera and just so many things appeal, like the technology and the consensus algorithm, which is mathematically proven to be the most optimum. But then really it was about like, can we trust like the people here? Because I mean, there are a lot. I'm just being a little bit facetious, but there's a lot of technologies. If you look at coin market cap, you're like, really? I mean, how could there possibly be like 7,000, you know, tokens out? I mean, like at some point you got to think it just doesn't make sense, right? So our thought was, all right, well, who can we trust? Like who is out there as the people running this? That seem like they're legitimate. They seem like they have a vision and an implementation that is going to be fit for purpose for healthcare. Because we're not in healthcare. We're not going to build something and 3 months later we're going to do a rug pull and disappear, or we can't be like anonymous building healthcare solutions. Nobody would seriously buy into that. So that was it. We kind of went down a rabbit hole with understanding what who Dr. Baird is, the mentor behind this, and Mance and the team. And that's honestly, it was a lot of it was that because in those early days, I mean, there was really no reason to believe Hedera was like something that had scale or would become what it is now, right? There was a significant leap of faith required, and I think we were actively involved and have been since to help them at least in this area of healthcare too, and providing credibility. And it's with these things, when you're that early, you have to find a two-way street if you can.
That's great. Thank you so much.
Yeah, of course. Any other questions? But by the way, our buddy Jake here, he's just a top rock star developer with Hedera. So if you guys are interested in Hedera and all this fantastic technology and agentic AI and stuff, I'm sure he will do a great job, providing you guys maybe like a demo or resources or talk or something like that. Cool. Okay. Yeah, if there's no other questions, I really appreciate you guys' time. That was great. Yeah, and happy to, yeah, if you're interested, just ping me on LinkedIn or X or whatever. I'm happy to be in touch.
Oh,
Yeah.
hang on, sorry, Jim. I just realised my mic was disabled.
Oh, okay.
I'm definitely happy to talk about blockchain with anyone on this call. I am at your university, just about. But definitely drop me an email if you're interested. I'm really happy to talk about sort of the technical side further. I do have a quick question though, Jim, if it's all right if I ask.
Yeah, of course. Yeah.
So one of the sort of ideas which came to my mind when listening to you talk is something that's not, I'm definitely not the originator of this idea, but the concept of there's probably is going to be people who, if they realize their data has value, would like to capitalize on that value. And I just wonder if you've sort of thought about this as like an offering, or if it's what the feasibility might be, where you can have people publicize their data, and anytime it gets used, again using smart contracts or public blockchain, every time that model, that data gets used to train a model, or every time there's inference on a particular model which is using their data, they get some fraction of a fraction of a fraction of a cent, which could potentially be a nice little bit of income for the data provider. Is that something which is discussed in the space at all?
Yeah. I mean, absolutely. And I didn't get into it because, we do a lot of things, not just what I've shown you, but I think you've seen, Jake, you may have seen this Health Token
Yes.
AI. So one of the reasons behind Health Token AI, and we're actually, again, I very quickly mentioned this, that we use this idea of an NFT and consent tokens and things, but we actually use Health Token AI for this consent tokens. It's used in the context of connecting data sets, but really our thinking is this technology, it's like an infrastructure for creating tokenization that can be used for things like exactly what you say, for incentivizing people to share their data, or to get some kind of it's always even like a residual on a smart contract or whatever. But then also things such as participatory AI. Like if you're going to say, hey, look, I have these agents that are going to be training, and this is a real example, I'm telling you. We have an agent that's using some of these counties we're working with, using their data for training on their real data. Well, then how do we incentivize them to have to participate and be like a participatory AI? And that's a part of it as well, is using this platform. So yeah, I mean, 100%. And then to be clear, you don't need to use, I mean, like Hedera, as example, provides native services for doing tokenization. Everyone does. But part of our thinking is, how do we make it easier? How do we abstract, things like the details of minting, or the details of creating keys, the details of interacting with wallets and creating accounts, and all these kind of things that when you're doing it for real, you have to consider.
Awesome.
Yeah. Thanks, Jake. Oops, that's not.
Okay. So I don't think there's any other questions. So Jim, I really do want to thank you so much for sharing your time and knowledge with us today. And to everyone that tuned in today, thank you for coming along. If you want to get in touch with Jim, we'll share his LinkedIn in the chat. But yeah, good evening, everyone. Have a good rest of the evening.
Awesome. Well, thank you so much. Yeah, great to chat with you guys, and I appreciate it. Hopefully, even if one of you guys like, hey, that was kind of, that maybe motivates me to learn a little bit more, I think that's a good thing. So, and thanks, guys. Enjoy the rest of the evening.
Yeah, thank you. You too.
Thanks. Bye.